Hi, myself Dr. Ansari Farzana Vaidusama, Department of Chemistry, J.A.T.rts Science and Commerce College for Women. Welcome all of you. The difference in lambda 0 value of sodium and potassium salt arise due to the difference in concentration to lambda 0 from K plus and Na plus ion, that means L0 K plus and L0 Na plus. The contribution from anion will be cancelled being common ion. By the equation we have lambda 0 KCl is equal to lambda 0 K plus lambda L0 K plus L0 Cl minus, and lambda 0 NaCl is L0 Na plus L0 Cl minus. Now subtracting the equation, subtracting NaCl from KCl, it becomes L0 K plus L0 Cl minus L0 Na plus L0 Cl minus. So here Cl minus gets cancelled. It becomes L0 K plus minus L0 Na plus. The same argument hold true for any pair of electrolyte, which is shown in this table. Calculation of lambda 0 for weak electrolyte. Two methods are used to calculate lambda 0 of weak electrolyte. Suppose that lambda 0 of acetic acid, a weak electrolyte, is obtained. Suppose that this method is based on Collard's law, a table of equivalent ionic conductance at infinite dilution. These values are given in this table. Now, lambda 0 acetic acid is equal to L0H plus and L0CH3CO minus ion, and from the table the value of L0H is 349.82 per ohm centimeter square, whereas L0CH3CO acetate ion is equal to 40.9 per ohm centimeter square. Therefore, lambda 0 of acetic acid is equal to, combine these two, then it comes out to be 390.72 per ohm centimeter square. Method 2. This method is based upon the equation lambda 0 is equal to L0 plus L0 minus. In this method, lambda 0 value of properly selected strong electrolyte are added and subtracted so as to get lambda 0 of the desired weak electrolyte. This method is illustrated for acetic acid weak electrolyte by Collard's law. We have, suppose that lambda 0 of acetic acid is equal to L0 of H plus ion and L0 of acetate ion. The strong electrolyte HCl and sodium acetate and NaCl. NaCl are considered. We can write L0 HCl is equal to L0 of H plus ion plus L0 of Cl minus ion. Similarly, L0 of sodium acetate is equal to L0 of Na plus ion and L0 of acetate ion. Then L0 lambda 0 of NaCl is equal to L0 of Na plus and Cl minus. Perform the operation, then lambda 0 HCl plus lambda 0 sodium acetate minus lambda 0 NaCl. It becomes lambda 0 HCl is equal to lambda 0 sodium acetate minus lambda 0 HCl. Substituting the equation of ions in this equation, it becomes L0 H plus L0 Cl minus plus L0 Na plus L0 acetate ion minus L0 Na plus ion L0 Cl minus ion. Then it is equal to L0 H plus ion. cancel the common ion. Cl minus plus Cl minus gets cancelled. Similarly, the H plus Na plus ion gets cancelled. Now remaining one is L0 of H plus and L0 of acetate ion is equal to lambda 0 of acetic acid. Now HCl, sodium acetate, NaCl are all strong electrolyte and their lambda 0 value can be readily obtained by extrapolating. Similarly, to calculate lambda 0 value of ammonium hydroxide, the strong electrolyte to be selected are ammonium chloride, sodium hydroxide and sodium chloride. Perform the operation. Lambda 0 NH4Cl plus lambda 0 NaOH minus lambda 0 NaCl. Now substituting the cation or anion, then it becomes L0 NH4 plus L0 Cl minus plus L0 Na plus L0 OH minus L0 Na plus minus L0 Cl minus. So here Cl gets cancelled, Na gets cancelled. In the last we have L0 NH4 plus and L0 OH minus. This method is illustrated in solved problem. Degree of dissociation of weak electrolyte. Any weak electrolyte is partially dissociated in solution. The extent of dissociation is described in the term of its degree of dissociation. It is the fraction of electrolyte that is dissociated into ion that are free to carry current. It mainly depends on the nature of electrolyte and are given and for a given electrolyte it varies with concentration and temperature. The degree of dissociation of solution having a particular concentration is proportional to lambda, the equivalent conductance of the solution at that concentration. The lambda 0 for electrolyte corresponds to complete dissociation of electrolyte. That means A is equal to 1. The ratio lambda upon lambda 0 then represent the fraction of electrolyte that is dissociated at a particular concentration of solution. This is obviously the degree of dissociation of electrolyte at that concentration. That means alpha is equal to lambda upon lambda 0. In case of strong electrolyte which dissociate completely in dilute solution, the ratio lambda upon lambda 0 is almost equal to unity. In concentrated solution, however, the ratio differs from unity. The departure arises not due to incomplete dissociation of electrolyte but due to the formation of ion pairs. These ion pairs are electrically neutral and hence do not take a part in the conduction of current. The conductance and hence the equivalent conductance of solution is less than value expected for that concentration of solution. In case of a strong electrolyte, the name conductance ratio is given by the ratio lambda upon lambda 0. Thank you for watching.